Hi, this is Port McGrath, and this is my BSAD 360 final exam. First question was to make a histogram to illustrate the distribution of household income in Colorado cities. So I create a histogram, um, and I change the bucket size to increments of 5 as it just fit better on the graph. Question two was to make a scatter plot of household income versus bachelor's or higher percentage, and to add a trend line. So I added a trend line, and then found out the equation, which was 0.999 multiplied by x plus 29.9, and the R squared value is 0.453. Pretty much the exact same again for problem three, which make a scatter plot between Trump vote percentage versus bachelor's or higher percentage. This graph had a very strong correlation. The equation was minus 1.35 multiplied by x plus 86.1. The R squared value is 0.548. Yeah, so problem three had a higher correlation compared to problem two. So R squared value was 0.548. And then for problem two, it was 0.453. Question five was to make a correlation matrix for all numeric values, and which correlation had the strongest and weakest correlation. So the strongest correlation was bachelor's or higher percentage and Trump vote percentage, which was negative 0.740, which is a very strong negative correlation. And the weakest correlation was unemployment percentage and Trump vote percentage, which was 0.038, which is very close to zero. So really not very much correlation. Question six was to make a multiple regression model to estimate the 2020 Trump vote percentage and to maximize both R squared and F. So I ran graph firstly with all the data, and then population had no significance at all, so I removed population, and then I reran it. And the correlation was better. And then the y hat, that's the equation here, 90.35 plus negative 0.18 by urban percentage, and so on. Then question eight was how much of the 2020 Trump vote percentage variance is explained by the independent variables in your model. So about 72% of differences in the 2020 Trump vote percentage between counties can be explained by this model, as the R square is 0.72 out of 1, which is 72%. Next question was to make a line plot to illustrate the time series of monthly supply of houses in the US and then label the axis. So yeah, I made a line plot. And I actually ran it first with the date, but I couldn't fit the dates down the bottom of the graph and the along the horizontal line. That just didn't look right. So then I tried it again with time period and made more sense. I then changed the bucket to increments of 10 as it just fit better. And I changed the vertical axis increments of twos as it just fit better in the graph. Then I had to find out the equation and the R square value, which the equation is 0.0721 multiplied by x plus 4.7, and the R squared value was 0.578. Then I added a trend line. And then I added a polynomial to the third degree. And the polynomial equation was 4.37 plus 0.0423x plus 2.96e, so on. And then R squared was 0.651. The final three questions. If one or more six were rolled, use this formula to figure that out. And the probability, I just averaged up all of E, and probability of rolling at least 1 6 was 0.412. And for the next question, if two or more sixes were rolled, probability of rolling at least 2 6s was 0.069. And then it's just the average of G2, which is the equation is here. And for the final question, the probability of rolling three sixes was 0.006 or 0.06%. Thank you for listening.